Assalamualaikum and have a good day, Dr. Izzah. In this video presentation, we will explain about the group project assignment of highway engineering subject, which the evaluation and enhancement of road safety features throughout the skid resistance, surface texture depth and drainage efficiency on UITM Shah Alam campus. So as shown here, this is our group members, which the first member is ARIF FARHAN, second MOHAMMAD SHAH, third MOHD Iman Hakim, fourth MOHD TAQIUDDIN, and last one SYED FAAIZ. Next, we go for the introduction, which this project evaluates three road surface type: rough, medium rough, and fine using the three tests mentioned. The skid resistance test measure pavement friction to reduce skidding risk. The outflow meter test check drainage capacity to prevent water accumulation and hydroplaning. And the last one, sand patch method, assess microtexture which affect friction and water flow. By analyzing this factor, the study aimed to understand how surface texture impact road safety and performance, which offering insight for better highway design and maintenance. This is the proper attire for the laboratory session. Now I will explain about the site selection and the problem. So for the first site was at landing slab staircase building 1 PKA and defined as fine road surface. The problem we found here for skid resistance tests are the low friction, abrasion or polishing, and contamination. Next, for sand patch tests are the uneven texture, worn areas, and crack or damage. Lastly, for outflow meter tests are the poor drainage, surface roughness, and ponding risk. Next site selection was at motorcycle parking level 2, categorized as medium rough road surface. In here, the problem we found for the skid resistance test are the presence of moss or algae, aggregate mold exposure, and uneven surface friction. For sand patch tests are the inconsistent microtexture and surface contamination. Lastly, for outflow meter tests are the impeded water found, water flow, ponding risk, and irregular flow path. Last site selection was at car parking level 2 and labeled as the rough road surface. The problem we face in here for skid resistance tests are the high friction variability, surface wear, and debris or loose material. For the sand patch test are the excessively high texture depth, non-uniform microtexture, and difficulty in testing. Last one, for outflow meter tests are the fast water drainage, localized pooling, and debris blockage.
Apparatus for the skid resistance for the parts are cylinder, leveling screw, scale, drag pointer, locking and control knobs, frictional ring. For the accessories are contact path gauge, water container, surface thermometer, and brush. Procedure for skid resistance test. First, place pendulum in release position and rotate drag pointer counterclockwise until it comes to original position. Second, inspect the road and choose the section to be tested. Set the apparatus so that the slider swings in the direction of traffic. Third, execute one trial swings. Next, make 3 swings and record the result. The reading should not differ by more than 3 units. Next, wet the test area. Make 3 small swings at the wetted test area and record the results. The reading should not differ by more than 3 units. Next, find another 2 more locations and repeat procedure 1 to 5 at each location. Lastly, report the individual values and also note down the condition, texture, and location of the test area. Apparatus for sand patch: a brass cylinder, sand brush, sand splitter, and steel ruler. Sand patch procedure. Number 1. Ensure that the test site is clean and dry by sweep all of the dust and other loosest particle. Number 2. Fill the brass cylinder with sand by dipping into the container and striking off any excess. Number 3. Tap the base of the filled cylinder on a hard surface 3 times and top up the cylinder striking off any excess. Number 4. Pour the contents of the cylinder onto the road surface into a small pile on the swab test site. Number 5. Use the sand spreader to gently work the sand down into the surface void. Work the sand down into the surface void in a circular spiral motion from the center outward until the diameter of the cylinder stabilizes and the sand have completely filled the void. Number 6. Measure the diameter of the circle at 4 evenly spaced diameter to the nearest 5 mm and record this measurement. Average the 4 readings to determine the average diameter of the circle. Number 7. Swab the sand off the road surface and discard. Lastly, repeat step 1 to 7 for another 2 test sites.
These are the apparatus that needed to use for outflow meter test. The first one is outflow meter apparatus, the second one is stabilizer board, and the third one is the stopwatch. These are procedures taken for the outflow meter test. First, the outflow meter is placed on a predetermined surface and the stabilizer board is fitted to the outflow meter. Then, two loads of approximately the same weight is asked to stand on the stabilizer board to stabilize the outflow meter. Tap water is filled into the outflow meter until the 400 ml gradation. The stopper in the outflow meter is open and the time for the water reach 100 ml from 400 ml is recorded. Step 4 is repeated 3 times for taking the average of water outflow. Step 1 until 5 is repeated at different places for smooth, medium and rough surface. The data collected need to tabulated.
Result and analysis. First one, the skid resistance test assess safety in dry and wet conditions. The fine surface performed the worst with skid resistance values of 53.33 in dry condition and 39.67 in wet condition. The medium surface performed better in dry condition 63 but dropped significantly in wet conditions 33. The coarse surface was the safest with values of 65.67 in dry condition and 62. As per TRRL 1969, a minimum value of 45 SRV is required. The coarse surface ensures the highest safety, while the fine and medium surface need improvement for wet. Next, the sand patch test measured surface texture depth, revealing that the fine surface has a mean texture depth of 0.328 mm, the medium surface has 0.522 mm, and the coarse surface has 0.918. As per IRC 15/2002, the required range is 0.65 to 1.25 mm. The fine and medium surface fall below the range, increasing the risk of hydroplaning and accidents, while the coarse surface meets the standard, ensuring better skid. Last one, the outflow meter test evaluate permeability through water flow rate. The fine surface had the lowest rate at 1.85 times 10 power negative 5 meter cube per second, the medium surface at 6.8 times 10 power of negative 5 meter cube per second, and the coarse surface had highest at 1.65 times 10 power of negative 4 meter. The result highlight the coarse surface as most effective for drainage, while the fine and medium surface show reduced efficiency.
As for discussion, the skid resistance test highlight variation in surface performance under dry and wet condition, emphasizing surface texture important in road safety. Fine surface show the lower skid resistance in wet condition, posing safety risk. Medium surface also drop significantly in wet condition, while coarse surface maintain high skid resistance in both dry and wet condition, making them the safest option. Upgrading surface with insufficient skid resistance in wet condition is essential to meet safety standard. For the sand patch test show the significance of textural depth for skid resistance, which is fine is 0.328 mm and the medium surface 0.52 mm, fall below the recommended, which is 0.65 until 1.25 mm range, compromising grip and safety, especially in wet condition. coarse surface, which is 0.9 wide 8 mm, meet the standard, ensuring better safety and adherence. For the outflow meter test, demonstrate the effect of texture and permeability and drainage. Medium surface exhibit the highest flow rate, making them optimal for drainage, while fine and coarse surface show lower permeability, potentially causing water accumulation. In summary, coarse surface excel in skid resistance and safety. Medium surface optimize drainage, and fine surface perform poorly in both, underscoring the need for texture improvement.
Coarse surface have higher skid resistant value, surface texture, depth and flow rate rather than the fine and medium surfaces that respectively, making it the most reliable concerning road safety. Also, it ensures improved grade and fulfillment of the safety requirements. For fine and medium surfaces, improving the surface texture is quite necessary to ensure safety and reduce the occurrence of skidding, especially when the surface is wet. Care must be taken in design to balance the drainage efficiency with adequate skid resistance for optimal road performance.